Hello, this is the first lecture from APBD. You already saw the materials, but I will make a small presentation and description of what we will be doing during this subject. Remember that if you have any questions regarding the task that you have to do, ask them on our Microsoft Teams chat, okay? On Teams, not on email, but on Teams. The code is in the announcement section, so take a look in here into the course list, internet-based studies. You should see in the announcement section the code for the class, and there ask the question, please. Okay, so next thing, what we will be doing, we'll be creating different kind of apps, mostly web-related, that allow us to communicate with database. We'll talk about different ways of communicating with database. We'll talk about creating APIs. And for that, we will be using .NET Core 3.1, which is Microsoft platform for creating applications. .NET Core is available on most of the platform, not only Windows, Linux, and so on. So of course you can install the one that suits you. I will be using Visual Studio. Visual Studio is an IDE. You can download it, and the free community version is enough for us, so we don't need anything else. Even though on software.py WSTK PG8K you have the full version. Remember that during the Visual Studio installation, I checked here the modules that we will need, so we don't need all of them. They would take a lot of space, so remember that. If you want to use another IDE, no problem, whether this is Visual Studio Code or Rider, IntelliJ Rider, no problem. And we will also use Git to version control and save our code. Okay, so and now the few things about, and remember one thing, I will be posting videos to lectures. Some of those videos were recorded during our previous semester. So remember that all the grading rules, everything is, the current information for this course is here for the grading rules, okay? Those are the grading rules. So you will receive a task usually and some time to finish this task. So you will receive a deadline, and the tasks should be published in here. Now, remember that you have to receive more than 50% of the points from the task, from the tutorials. Tutorials are graded usually 0 and 1, so if most of the things are finished, I'm giving just a 0.1 for them. Probably there will be around 12 tutorials, something like that, till the end of the semester, and till the end of the semester, during the exam session, you will have the practical exam, which you have to pass, which will you have to code on the spot in our building. You will have to create a small app according to the requirements. So we will be mostly talking about also different kind of patterns for objective programming, for creating different kind of web apps. We are using C# language and .NET Platform as an example of that, but of course a lot of those things will be usable also if you are using a different platform. Now, C# code actually, and the .NET Platform, just to very quickly describe it, is a platform developed by Microsoft starting around 2000. And actually, till now, the platform is in development. At the beginning, it was mostly connected with Windows servers. Now, .NET Platform, especially .NET Core, can be run cross-platform on different type of operating systems. The way how .NET Platform works is very similar to JVM. So usually we write in some kind of language. We will be using C#, but actually you can use VB.NET, you can use Python, Iron Python, Iron Ruby, which are versions for .NET of those languages like Python and Ruby. We will be using C#, which is very similar to Java. During the compilation, what we get is something called bytecode, which is actually precisely called intermediate language. And then when we send someone this code in the form of DLL, let's say, they can run it on their own computers using just-in-time compilation and something called CLR, which is Common Language Runtime. CLR works kind of similar to JVM. So the idea is that we write the code once, compile it into the intermediate language, and then we can run it on multiple machines as long as they have the CLR installed. So kind of similar like in Java. Now, here we have explanation of the things that I just quickly mentioned, of course. And as you see, just to kind of show you, the stack of the technologies is very similar. So we have JVM on different operating system, bytecode, and languages. In here we have CLR, MSEL, which is Microsoft Intermediate Language, and Windows. Currently, this part is not exactly true because we can run .NET Core on Linux and all the other platforms that we know from JVM. So it's a fully cross-platform now. Now, second thing, .NET Framework, .NET Platform consists of different kind of libraries, which are usually called BCL, Base Class Libraries, or FCL, Framework Class Libraries. So kind of like in Java, we have different libraries, collections, networking, input, output that we can learn about and use them. And same thing in .NET. We can just learn about them, use them in different technologies and in different applications. So we will learn a little bit about some of them as an example of certain, let's say, approaches to solving different kind of problems. And then, of course, most of the things that we'll be discussing will be also usable if you will even switch the language, because we will also talk about some patterns and some way of approaching the problem that should be useful if you are using even a different platform. Here we have some information about .NET Core. .NET Core is a little bit newer platform released not so long ago, around 2016, and actually it is cross-platform. So .NET Core, the main difference is that it was developed with the having in mind that it should run on multiple platforms. So that's something interesting. So here we have a kind of breakthrough of different app models related to .NET Core. So soon, actually, .NET Framework is kind of merging together different frameworks. So we will get something that is called .NET Standard Library, which will be useful to run to create apps on .NET Framework or .NET Core or Xamarin, which is a cross-platform, cross-mobile platform solution, and so on and so on. You can read a little bit more about it in here. But it's not that important from our perspective, unless you are interested in .NET platform. So C# language. Here I'm adding two links to two sources of information about this language. We will learn about this language as we go. It's quite similar to Java and C++, so when it comes to basic syntax, you should already be you already know a little bit about it if you know Java. Version control systems. During our classes, we will use Git version control system. Git, which is a console tool for saving the changes in your repository, in your code, and working remotely with different team members and so on. So basically, version control systems, especially Git, is something that you need if you are working in any kind of company. So I would also would like you to use it to send and create the tasks that you have to do. We'll make a small, and you have here also two links explaining what is Git if you don't know it yet, because I know that there's usually part of the students who are using it actively and part of the students who haven't yet started using it. So here you have some information about them. So that's one thing. I would like to turn on the tutorial one, just to quickly go through what you have to do. So in the first tutorial, the main thing is to kind of get accustomed yourself to the C# language, to Visual Studio, and to working on .NET platform. So first of all, there is a small task about creating Git repository. So we will be using GitHub. So the best thing would be if any of you who are solving the task would create the user on github.com with your index number in the name of the as the name of the user. Okay, and then I will go to the details of my user. Okay, when you create the account, you can create repositories on GitHub, which are kind of places in which you can store code related to the specific task. So I will create a new repository. Let's call it APBD test. You can create the description of the repository. You can make it either private or public. I would like you to create it as a public one, so I will be able to see what is inside of it, and you don't have to give me permission. You can give description if you want, and you can add readme file and git ignore. So those two files are pretty useful. You can add the license to say that, for example, your code is open source or something, but please add readme and please add git ignore. And git ignore is a file that is used by the Git system to ignore certain files that shouldn't be stored in the repository. So for example, when you are compiling code from the source code, you will get usually different products and subproducts of the compilation process, like DLL, class files, and so on. We don't want to store them because they can be generated after with the compilation process. So in here, I will choose the git ignore for Visual Studio, and this will prevent me from saving a lot of the trash that I don't need to save. And then create repository. Okay, so after you created the repository, you will have a file like that, and you will immediately have two files inside your repository, git ignore and readme. So git ignore is just a list of folders that we should ignore, a list of folders and files. So for example, everything in the bin folder should be ignored. This is basically what this line is saying. And the bin name can be written with the uppercase or lowercase. So this is kind of like groups in a group in regex. Yeah. Okay. So this site, github.com, is actually not related with Git, because Git as a tool is actually just a console tool. So you could use Bitbucket, you could use different web servers, different providers to save your repositories. But Git in itself is just, as you see, a console tool. Git was first developed by Linus Torvalds when he was working on the Linux kernel, just for himself to save the changes and track the changes in code while they were working on code. Nowadays, Git can be used with github.com and with multiple other places in which we can store our code. Yeah. So Git allows us to save the history of the changes in our code, and github.com allows us to save our code in the form of a repository. So you also have here readme, so it would be great if you could just add also here the name of that exercise. So let's say the name of the tutorial, that this is a solution for tutorial 2, let's say, and you can just commit the changes. Okay. Okay, so readme is just a very special file, this one, because the content of this file is being displayed in here. So of course readme contains usually some additional information, how the code should be run, how to configure it, and so on. You can see an example of that if you will just go to any kind of public library, for example. Yeah, so you can see the description of the repository. So what else? If we have the repository prepared like that, you can click code and you have the option to get the URL for the repository. I will just copy it. Now I would like to download this repository on my own computer. So let's take a look. I will open the console tool. I will switch to desktop, maybe switch to downloads, because I want to remove it later. And you have to have the Git tool installed. In the PDF, you have the link to the website from which you can download Git. So if you will type Git enter and you will get the list of commands, you're ready to go. If you don't have it, then probably you have to install Git on your machine, whether this is Linux, Windows, or anything else. So the first command that I will use is git clone command, command to download the repository. And as you see, I fetched the repository, I downloaded it. Now, when I will open the folder, you will see that I have the folder APBD test, and inside of it I have gitignore and readme, but I also have very special folder which is called .git. And this folder is very important because inside of it are all the internal informations required by the Git to work correctly. So remember this thing. So when I have this kind of folder, any code that you want to save in the repository goes in this folder. It means that this folder is under the version control system. It means that we can save the changes in this folder. Okay, so for example, I will open Visual Studio, and let's say that I want to create the console app. So I will create new project. And remember, when you are working here and you are typing, let's say, console app, I have much more templates, of course, but you don't need them, templates for different app. You see that I have console app.NET Core. Now I will select it, .NET Core. Remember to have a .NET Core and C#. And I will change the folder in which it is stored to APBD test. Okay, I will call it example1, and you can call the solution the same name. So you see, we have the project name, location, and solution. What is the solution? Solution is just the name of the container in which we can have multiple projects. So if you have much more complex projects, usually your project can contain your solution can contain multiple projects. For example, we could have solution called Piatk, and inside of it I could have desktop app, mobile app, console app, web service, and so on and so on. So let's create it. And you see, I open it in here. And this is my code. So I have hello world, and this is the Visual Studio. The code is quite similar to Java. There are just sometimes a little bit different keywords like namespace instead of package and using instead of import. So apart from that, they will be very similar. And if you want to run your code, what you have to do? First, you can go to the debug option and you can run the code that you write in two ways. You can click either start without debugging, which will immediately compile it and run it. And I got hello world and the program finished. Or you can run it in the debugging mode, start debugging, which means that if you will put any kind of debug stop points, the execution of the application will stop here and you can just see what are the result, what are the internal variables, and so on and so on. So we will use this in a second. So when I created this project, let's say that I would like to save it into my repository. So what you have to do is, you have different tabs on the left and right side. A few tabs that we will need, apart from running the app, as you saw, is actually the tab that is called Team Explorer. And remember one thing. Anytime you don't see a name of the tab somewhere in here or here, you can always go to View and find here Team Explorer. Or if you completely messed up this view, because maybe you just dragged and dropped a lot of windows in different places, you can always go to Window, Reset Window Layout, which will help you in this case. So I go to Team Explorer. I have here a few tabs. Now I have the tab called Changes. When I click it, he will show me exactly here. So this window, Team Explorer, is actually working with Git. So if I created the project inside of the folder, which has this .git folder, which means that this folder is under version control system, it means that if you will go to the Team Explorer, you will see that I can take a look and see what I changed in this repository. So you see, I have information that I added 3 files, example1, program, and example1 CS project. And let's say that I would like to save them into my repository on the server of GitHub. So first I add a message, added initial project, project, and then I can do commit all or commit all and push. Usually the best thing is to always do commit all and push. So two commands at once. So commit all and push, and I wait a second. This is my commit, and the commit is saved in here. So I get back in here, I refresh my page, and I got my code in here. So the question is, what are commits if you didn't use Git? So very quickly, there's a lot of materials about that. Git actually stores the history of changes in the repository as commits. So when I have one commit, and let's say I added the two files in here, which will be readme and git ignore, then I created another commit. And commit is simply something that has a date, an author, a special unique identifier of this commit, and that's it. So let's say when I created another commit like that, this is my commit. This commit has a date, author, and it also has changes that I introduced to my repository. So we can say that Git repository stores the history of changes in the form of queue, and the elements in this queue are called commits, and each commit represents changes from the last version of the repository. So let's take a look. If I will go to my here, to this one, and I will say added new comment, and I will go back, and again you see that again in the changes I see that this file was modified. I added this comment. So let's right click and choose compare with the unmodified version, and you see he will show me that I added this line of code from the last version that was saved in the repository. So now I can say added new comment, and I can just commit all and push. Okay, so why we are using commit all and push? Very quickly, if this is our server and this is our desktop computer, we can say that on the server we have the master branch and we have our repository safe with 3 commits, let's say. Then, using the clone command, you are actually cloning the whole repository and the whole history to your own computer. So the benefit of that is that Git is a distributed version control system. It means that you can work offline. You have the whole history on your own computer. Even if the server will go down, you can recreate the whole repository from the single copy. So when you create something like commit, you create the commit in the local history of this desktop computer. So I created one, and let's say I created 2 commits, but they are not on the server yet. So this is the command that is called git commit. The git push command, this is why it's called commit and push, is actually taking those 2 commits and sending them to the server to finally have it also save the copy of those 2 commit on the server side. Yeah. So I'm going through it very quickly because I included a lot of materials about it, and I'm pretty sure that all of you, or sometimes most of you, already work with Git. So this is how we work. So every time I change something, I create a small commit and I save it to the repository, and then I can very easily here go through the commits. As you see, I can go and I can go through code in here, or I can see a list of commits in here. So you see I created 2 commits, then another 2 commits. I have the time, I have the name, I can click the commit and I can see exactly who did what while sending this commit, what kind of changes he introduced. So this is pretty useful, and this is a must-have when you want to work in any kind of company. So if you would like to have more detailed explanation of Git and it won't be clear, then let me know on Microsoft Teams, okay? Because I'm going through it very quickly, assuming that most of you already work with it and know it. However, it's not always the case, so if I'm wrong, then of course let me know that you would like to learn a little bit more about it. So in the task 2, we created the repository, and and we are making a small thing. Maybe one thing before I will let go of this topic, I will create another command and just show you that all the things that we did from here from Visual Studio can be done from console. So I am inside of my project. If I will type git status, I can take a look what was changed. You see, I modified a single file. When I type git diff, I can quickly see what was modified in console. Then I can decide which changes I want to save by using the git add command. Git add dot means I want to save all the changes I did. So if I will say git status again, he will tell me that those green changes are the next one that will be committed, which means will be saved. Sometimes you don't want to save all the changes, yeah? And then I type git commit with a message, so M stands for message. And now this commit is only on my computer, so I have to push it to the repository, like that. So now I pushed it to the repository, and is already saved on my in my GitHub. Yeah. So all the steps that I did now are actually the same thing that we did from here. When I say commit all and push, I put the message. This actually made the commit. So you can work from console or from Visual Studio, no difference. The truth is that Visual Studio have a lot of different tools, but actually they don't allow you to use all the Git functionality. So there are some commands in Git, quite a lot of them, that you can only use from the console. Okay, so in this task, what you have to do to get kind of accustomed with Visual Studio and with project in this IDE are a few things. So first of all, in Solution Explorer, this is the window that we'll often use because it displays the content of our project. We can see that I have program.cs, a single file with the main method, and I have dependencies, which means just a default libraries connected to my project, just like in Java projects that I can use. Now, every time you run your code, you will actually see that on the folder, you got two files, few additional files that we don't see in here. So I have something called CS project, and this is actually an XML file that we are not messing with usually. It contains information how to compile our app for Visual Studio and so on. So usually we don't modify it by hand. We can, but we won't be doing that. So we're just leaving that. Then we have the OBJ, and this folder is just, let's say, a sub-product of the compilation process. So every time you run, you click run, this project will be recompiled, this folder. So you are just not touching that. And in the binary, we have the compiled version of our app, which is available every time after we finished compiling the app. So if I will open PowerShell here, and I have my Hello World app, or example one, I can, as you see, run this app like that, and it is executed. So right now I'm executing this code using something called CLR, just as I could run code using Java command if I would have some class files in here. Usually the compilation process gives me out the DLL, which is dynamic link libraries that contains IL. We have the PDB, which is program debug database. This is used for debugging, so it's not necessary, but it's maybe useful. We have some JSON configuration file that we are not using yet, so those are also, let's say, not necessary. Yeah. So basically, for our case, those two files are necessary. However, all those files are being recreated every time you push run, or run with debugging or without debugging. Yeah. So in our small example, before we will be connecting with databases and so on, I'm creating something that is called HTTP client, and we would like to download some. So I will create HTTP client to download some web page. Yeah. HTTP client has a method dot, and as you see, we have the tooltips, of course, which is called getAsync, where I can put the name of the web page that we want to download. So I will choose our school web page. So I will choose pga.edu.pl. Yeah. Okay. And I want to save the whole website to string. So you may think of what is exactly when I'm saying var. First of all, in C# language, a few small changes in relation to Java is that you can use the string with the lowercase. This is just syntactic sugar. This is the same thing as writing it like that. However, in Java, in C# the convention is that we're using the lowercase. Next thing, if you are creating the variable, you can often use the var keyword if you don't want to specify the type twice. So you can write it like that, but you can also write it like that. It means that this is still a string value. It's still a statically typed language, but the type of the variable is just deduced, let's say, from the data or from whatever is on the right side of the equal sign. Yeah. So here I'm using the method which is asynchronous method. So I have to await the result. About this, about await, we will talk a little bit later about. So I will just add here async, and this is how we can run this code. So don't worry about the async. We'll talk a little bit about this later. So async actually allow me to wait until the server will return the web page, and only then I will assign the result and just go on. Because if we wouldn't use async await, then the result could be null and the code would just go on and finish without waiting for the server to respond. Yeah. So now I will create a breakpoint in here and I will run the code in debugging mode, which is debug start debugging, or in here example 1, and run it. This is debugging mode. If you have any kind of error, you will see that you will get something like this, that we have some kind of error. So if you cannot run it, you have compilation time error, you have something like this. I will have to fix it like that. Okay. And I run it in the debugging mode. And as you see, I stopped on this line. I'm in the debugging mode, so I can hover over the result. And as you see in the debugging mode, I can see the internals of the variable. And I can see that we got OK 200, which means the server returned the success status code, and I got the result back. So now I just like to read the content of the web page, which is just an HTML code. Okay. So if you want to get back to the editing of the code, click Stop Debugging. Okay. Okay. So what we can say that if the result is success status code, we can do something, and I can say, let's say I would like to read the content of the whatever the server return as a string value. So I got something like this. And then I will just print it to the console. Okay, so let's run this code without debugging. And wait a second, and we should get the HTML content here. So we are waiting. Okay, and I got back, as you see, the content of the web page, not formatted nicely, but this is our web page. So Now with this content variable in here, I could do certain things and let's say look through it and so on. So this is a kind of very simple web crawler, let's say. We are just downloading the result, the web page, and then we are going through it to get some data. So right now, this is the part of the code to start with. So we will discuss the await and async pattern a little bit later. This is just the beginning. This is enough to get you started. To finish the rest of the task, you won't need it. So we have the beginning, and then in the task 4 and 5 that you have to do a little bit on your own, we have to add a few different things to this example. So in the case when the parameter 1 has not been passed, we should throw argument null exception. So what we want basically is that we want to get this URL from the argument. So usually I can just replace this with arg0. And we want to be able to pass the argument to the getAsync method through the console. Yeah, so you remember, just like in Java, this part allows me to pass the data through the console if I want to. And when I click now, right click, properties, in the build option of the app, you can edit various things related to your application. And you can also, okay, so if we want to pass the console arguments and in here, every time we run the app, we can go to the debug section and we have application arguments. In here, I can just type the URL in here, and when I will run the app in the debugging mode, you will see that in the args, I have this argument passed in. And now basically every time someone will run this app as a console app through here, yeah, through here, they can actually just run the app, example 1, and pass the parameter in here. Yeah, so we basically want to create a small utility console app that we can just pass the URL, and the website will just download this URL to do something. Now, in the task 4, we need to add some additional validation. So if someone didn't pass the argument, we want to throw the argument exception, and throwing exceptions works exactly like in Java. We should remember that we should dispose of the resources associated with the client class. So there's a dispose method for that. So if we are finished at the end of the app with using the HTTP client, we call the dispose method. And also we would like to change this app a little bit so that it allows us to find email addresses. So for that purpose, you will need a regex class. So you will have to take a look. In the lecture material, there is a link for the C# language, and you can find how the regex class works. And actually, the regex class works pretty much the same as in Java. So you will need to create a regex class that will allow us to go through the string value and extract all the email addresses. And in the last task, there is just a small question that you put the code from the task 2 on a separate branch in the Git repository. So this is related to Git again. Usually when we are working on a single repository, we can have multiple branches showing us the different versions of the code. So you are asked to create a new branch, put your code on this branch and push the changes, and that's it. So if working with the branches, you don't know it yet, if this task is a little bit too hard, let me know on MS Teams exactly what is the problem, and I will be just posting additional material so that it's easier to finish the task, and then we will continue. During the next task, we will continue on, and soon we will start communicating with the database. We will talk about different problems while communicating with database, what we have to worry about, what we have to keep our attention on when we are communicating with database, and so on. So that's it for today. And please contact on write on MS Teams if you will have any problems with this task.